Thanks for joining us for another episode of DPC Radio. This episode was recorded live in Amsterdam at the Dutch PHP Conference 2012. For more information about the Dutch PHP Conference, visit our website, phpconference.nl.
How many of you have used ElasticSearch before? Or at least looked at it? Heard about it? No? Okay, cool. So, I went on Twitter and I searched for ElasticSearch recently, and I found this tweet that said, "Elasticsearch is so damn good, I want to cry." I wanted to like that, but it wasn't Facebook, so I don't know. It's truth. This is a little bit about me in the Elasticsearch format. I work at a company called AppDynamics. I'm not going to tell you what it does. It's sort of enterprise-y startup. I've worked in the past on PHP, being core developer for a number of years. Then PHP GTK project came along and did Smarty. You can love me or hate me for that. I did Unicode internationalization thing in PHP, which was supposed to be PHP SIG, but never saw light of day, really. I like coding. I like beer. Awesome beer in Belgium and Amsterdam and Netherlands. I like brewing beer, too. If you like any of that, come and talk to me after. I like photography. I'm @A on Twitter, which is awesome and horrible at the same time, because you can't imagine what my reply stream looks like, although I have plans to fix that because Twitter won't. And you can email me that email address if you have questions. So, what is Elasticsearch? In the simplest way, it's a search engine for the NoSQL generation. It's built on some previously existing technologies, but it was built from the ground up to be a domain-driven and document-oriented search engine. So it adapts to any sort of domain problem you might have. It's distributed out of the box, and it's very easy to get it clustered and sharded and all that good stuff. It's RESTful, so it works over HTTP REST-based protocols. And it uses Lucene as its engine. And since Lucene is pretty awesome and has a lot of development going in there to make it stable and fast and all that stuff, Elasticsearch benefits from that. A year ago, it's not really a release product as far as if you look at version numbers or whatever, but a year ago it was a 0.15 release, and they just 0.19.4 came out. But there's always continuous progress, lots of new features that are being added or things fixed and so on. Pretty active community around it, and the increasing adoption in the last year, a couple of years, from small and big companies like Sony Computer Entertainment, StumbleUpon, Assistly, a bunch of other companies that are using it as their main search solution. There's no cloud hosting option yet that I really know about, but maybe soon. Maybe Combel wants to offer it. Is there? Me? I'm one person. Come on. Some API conventions that you can use with Elasticsearch, and I'll sort of rely on. You can append pretty equals true to get readable JSON to any URL to get nicely formatted results back. If you want to use Boolean values, it's false, 0, or off. Everything else is true. And if you want to use JSON P support, you just do callback equals the name of your JSON function. Your JavaScript function if you want to. That's JSON P2. And the API structure for Elasticsearch looks something like this, where you have a host and a port where you're at least one of your instances of Elasticsearch is running in the cluster. And then everything after that is optional, depending on what API call you're doing. Usually it's index, basically what container for the documents you have, and then followed optionally by type of document. And then depending on the API, it can be either a document ID or an action. So you can do things like fetch status of the cluster fetch status of the Twitter index, fetch me a tweet from numbered 1, or do a search on the Twitter index and tweet document type. Or you can search across document types if you store multiple document types in there, or search across indices or all kinds of things like that. And what you get back is JSON formatted. Well, it uses JSON both for results and for queries itself. This is an example of a query, so it's kind of JSON-based query language. If you look at it, it's a little bit, maybe a little convoluted, but there are client libraries that make it a lot easier to write this stuff. but I'm just going to rely on doing it all in JSON. So 3 easy steps to getting to work with Elasticsearch. One is you index your stuff, obviously. So I'm just going to, let's say, index something about speakers of this conference, and I'm going to put it in the conf index /conf /speaker is the type of document, and then I'm just going to number it, give it document ID 1. If you don't give it a document ID, it generates this long UUID string, which you're welcome to use or provide your own. And what you get back is a response that says, okay, everything went fine, and it put it in the conf index type speaker and document ID 1, just confirming that everything went well. And then after that, you can do search right away. You don't need to wait or anything, or reindex, or restart, or nothing like that. So you issue a query against the conf index and speaker documents, _search, and you just say q equals beer. And it gives you back this document in the response, which contains a lot of interesting things, so we just step through them quickly. So you get a total number of hits that matched for the documents. You get the index of the document that matched, because you may be searching across different indices, the type, the ID of this document that matched, the hit score, which is not really a normalized number, but you can sort of order by that to get more relevant documents up top. And then it actually gives you back the original doc contents by default. So it's very useful. You can just fetch that and then take the original document and do whatever you want with it. It also gives you back the execution time, which is, in this case, I guess is 3 milliseconds, which is pretty good. Of course, we only have one document, probably. And then you profit. That's up to you, really, how you use this technology to make a lot of money. So let's go play around a bit just from the command line. Does everybody see this? Is this big enough? Yes? No? Good? Okay. So I'm just going to go and index a few speaker documents here, a few speakers for me, for David Zulke, who is on the train right now, hoping to make here in time for his talk, and then Elizabeth Smith. So I have an instance of Elasticsearch running here. If I go and do something like this, it's going to give me, say, okay, this is status version number. It names gives really cool names to every instance in the cluster. This is Lon the Sorcerer, apparently. So let's just put that in, okay? I put in 3 documents about speakers, and then I also have 3 talks for those speakers. So I'm putting them as different document types in the same index. Let's do that. Now let's do a couple of searches. So, okay, we want to search for query David. Let's see if it finds him. Oh, there he is. There's David Zulke. Or if we want to search for speakers that like cars, that's also David. We can use an AND operator. We can say coding and beer. And it comes back with me. And notice we don't have to actually say what what field we're searching against. It sort of assumes you want to search across all fields, which is pretty convenient, but can be customized. We can actually search against a specific field here. Let's say name Colin Smith. So that's Elizabeth, who gave a pretty good SPL talk this morning, from what I heard. And then you can search with description, and here it comes back against found that talk that has PHP in the description. You can search across types. So here I'm searching at a conference index for speakers or talks that match PHP. And if you look at it, it comes back with David, who likes PHP encoding, and Elizabeth, and a talk. So you can mix and match your document types or indices. You can bring back only selective fields if you want. So here I just want the name and the likes fields rather than everything. Here it gives them back to you in the documents. Come back. You can do fuzzy searches. So let's say I didn't know exactly how to spell the word engine, which I actually see a lot. But I know I have at least first 2 letters right. So I can do fuzzy search here, fuzzy query against description with engine, spelled like that, and prefix length of 2, just to help it a little bit, to make it faster. And if I go and do that, Oh, there you go. It found engine, which is actually, I should probably do this. There's engine here somewhere. There you go. I can do a Boolean search where I can say results must contain coding, but let's say we're searching only for tall speakers, right? So let's say not below 188 centimeters in height, which should bring back David, hopefully, because he's pretty tall. And there's David. So there's a Boolean query. You can use a query string, sort of like if you go into Google and type web, but I don't want it to match hypermedia and all that good stuff. So you can use a query string like that and say that I want a default AND operator rather than OR. Go ahead and do that. Oh, there it comes back with that talk again. You can do phrase searches, and what's cool is you can use this thing called phrase slop, where if you're searching for a phrase like event programming, but you don't know if there's something in between there, you can say, okay, well, I'll allow up to n words in between. So here I say up to 2 words, and so if I search for that, I come back with a stock which has event-driven programming, but I just specified event programming. So that's pretty cool. I can do search highlighting. So here I'm searching for event in all fields, and I want to highlight the fields, the hits that come back. So if I do that, it gives you back this highlight result where the hits are wrapped in em/em, which is customizable if you want, but basically helps you, bolden or do whatever you want. And then there are other things like facets, which I'll talk a little bit later. So the distributed model for Elasticsearch, now that you saw a little taste of that, is basically it was built for performance and resiliency. You can run it on one machine, but it's way better if you run it on at least 2 machines, just for failover purposes and for performance and all good things like that. It has 0 configuration discovery out of the box, so if you start up 2 instances of Elasticsearch, and in the configuration you give them the same cluster name, they'll find each other on the network, and one of them will be master and the other will be slave. And that's it. You don't really have to do anything. And it's even easier on Amazon EC2. So getting a cluster running is literally like 5 minutes, maybe even less of work. Sharding replication is built in. It has a lot of controls on how that's done. You can have however many shards you need for your document collection, and each of those shards can have as many replicas as you need, depending on how many instances you can afford to run. And what's cool is that once you have your cluster running, it has auto routing, so you can actually send queries to any server in the cluster, and it will handle it. You don't have to send it to master, which will propagate it to slaves and so on. Any server in the cluster can accept queries and return results. And I think I have an example of that later. And then each shard, like I said, can have 1 more replicas. And this number of replicas can be updated dynamically after you create the index. So you can start your index with just 1 replica, just to have a copy of your data for security and so on. But let's say if you wanted to scale it up a little bit and be able to query from multiple indices later, multiple replicas later, you can update it after the index is created. And the way it does shard allocation, just to illustrate that, is let's say you start with a single node, you only have 1 machine running, and you want to you configure the shards. It's all done by HTTP. So you say I want to create this person index, and these are the settings for it. I want 2 shards, and I want 1 replica. And 1 replica really means 1 copy. So you're going to have 1 copy other than the master copy. So you're going to have 2 of them. And then let's say you start a second node. So it's going to take those 2 shards and put the replicas on the second node. And then you start 2 more nodes. And it's going to take the copies of those shards and move them to the other one. So now every node has at least one replica for the shards. And actually, that's the max you can get because you only had 2 shards and 2 replicas, so you only have 4 total indexes. And then, let's say you wanted to index a document. So you say put a person index, let's say it's info document type or whatever, and let's say it assigns it hashes to shard number 1. And it gets automatically replicated to the copy of that shard on the node 3. And let's index another document, hashes to shard 2, and gets replicated to node 4. And then if you do a search, you're searching against that index, you can query any one of them. Let's say we're querying node 1. It'll automatically go and query both shards to figure out where the documents are. It'll go do the search, collect the results back, and then return them all to you. So that's pretty cool and easy way to do it. Transactional model for Elasticsearch is per document. So you're guaranteed that if you index a document as a whole, that it either gets indexed or it doesn't. It's not going to partially index a document, let's say even if the server goes down or whatever. So you're always guaranteed that. It uses a write-ahead transaction log to keep track of that, like the good transactional systems. And it has a 1-second index refresh rate by default. So if you index a document, and about a second later, it will be available for search. But I think in later versions, they actually even remove that limitation. So it's immediately available for search as soon as you index that. Or you can configure it later and refresh your index. Let's say if you want to put in 10,000 documents and just refresh it at the end, you can do that as well. You can also say that you can give it when you're indexing, when you're setting up an index, you can give it a parameter saying, I actually want to guarantee that this document gets replicated to. Actually, the operation completes if it gets replicated to at least 2 or 3 servers, for example. Even if we have 5 replicas, as soon as it hits 2 or 3, then when it's guaranteed, not when it gets indexed into just 1 replica. And so you can sort of control the consistency, transactional consistency that way. Of course, if you index documents, you need some sort of storage where the index data is kept. And that can be in a number of places. It can be a local file system. It can be a JVM heap. By the way, this is all written in Java and runs in Java, but it's not a reason to be afraid of it. It's actually really good and stable software. It can be a native OS memory or some sort of combination. But the thing about that is that node data is considered transient. So if you index a bunch of stuff, but then your machine goes down and you bring it back up, it's not guaranteed that the node data will be there. If you want to have persistency, then you need to configure what's called a gateway, which is a persistent storage mechanism, and can store your index data also in a number of locations. Local file system or shared file system like manifest, which I don't know if you really want to do that, or Hadoop file system. There's Amazon S3 option. And what Gateway, what it's basically used for is that if your cluster goes down and you need to bring it back up, it's going to, so you don't have to reindex it, basically it takes the data from Gateway, fetches it, and rebuilds the cluster from that automatically. And usually local storage is pretty good, especially if you have a number of machines running, because the chances of your entire cluster going down at the same time are fairly small, which can happen, of course, but you can mitigate that, or you can store it all on Amazon S3 or something like that. Now, there's a concept called mapping, which is basically a description of the document structure that you're going to index. By default, it just tries to figure it out automatically with some sensible defaults. So if it sees a number, it assumes it's an integer, unless there's a floating point. If it sees a string, that's going to treat it as a string. There's a date, string that looks like a date or time. But you can override it per field and just give it more information about what you're trying to index. And there's many different field types that you can index in Elasticsearch. String, integers, floats, booleans, dates, geo points, arrays of data. So like if you want to have a document with tags, and it automatically figures that out, or you can configure that objects, sort of JSON objects, and a bunch more stuff. So here's an example of sample mapping. If let's say I wanted to index some blog post data. So my document looks something like where I have user title, tags, post date, and priority for some sort of ordering. I can create a mapping like this, where I say properties for the post document type. User is a type string, index not analyzed. In this case, I just want to store it there. I don't want ElasticSearch to actually run any sort of language analysis on it for search. For message, it's a string, but I want to boost it 50% when I do a search across all field types. Tags is a string, but I want to include it in the all field type, which gets generated automatically. Basically, all field is a concatenation of all the other fields, so you can search across all of them rather than specifying which one you want to do it, which one you want to search against separately. Post date is of type date, but I don't want to store it in the index. I just want to have it available for search. And then priority is an integer. And really, you don't need to give it the last one because it figures it out automatically. The cool thing about this is that it also does auto-merging of these mappings. If you later want to update your message to different boost, or you want to add a field, you just need to specify those changes. You don't need to redo the whole thing if you don't want to. And one concept that it has when working with the textual data is analyzers, which are different basically plugins that tokenize and text into tokens and normalize them during indexing and querying. They do a lot of interesting things. And by default, what they do is just do standard tokenization on text, separate by spaces, periods, and so on. And then it lower cases it by default, so that you can do case-insensitive searches, and applies some sort of stop word filter, where it throws out, in English, words like a, the, in, of, and so on. And other languages have different stop words, of course. But when I was working on a project, I also wanted to do something where I wanted to be able to search for words ignoring accents. So if there's a word like cafe and with an accent, I just wanted to search for cafe and have it find both of them. And the way to do that is you can basically build a specified custom analyzer, and this is in your ElasticSearch configuration file, where you can name a custom analyzer. I called it ulang for European languages, and I do type custom, tokenizer standard. And then those three filters are standard, but I appended ASCII folding, so it does that ignoring accents thing. And also Porter stem filter for doing things like if you want to search for fishing, but it also finds fish or fishes and so on, just basically the stemming algorithm to give you better, more search results. And then once you have this mapping specified, once you have this analyzer specified in your mapping, you just say type string and give it the analyzer name, and it starts applying that to the text when you index the text and query it. So the next next concept is filters, which is similar to queries, but they actually reply to the results of the query. And they share a lot of similar features, but why would you use a filter if they're similar to queries? Well, they have some advantages. One is they're faster, because most of them are cached in the memory, and which depends on the filter by default, but can be turned on or off. And this filter cache is used for different queries against the same filter. So if you want to filter out on, let's say, all the documents that are newer than 20 days, and then run different queries against it, different text, it's going to use that cache that is built up. It also doesn't do any scoring. The scoring can be a little, depending on various configurations, can be a little time intensive. So if you don't do scoring, it becomes better. It becomes faster. And then some of the more useful filters that you can use are things like prefix, terms just for keyword searches, ranges for numbers, and so on. Okay, facets is a really powerful thing in the search engines, and it basically allows you to get some sort of aggregated data based on the on the results of the search request. Usually, what has been used for is some sort of faceted navigation. You've probably seen it where you go to search results somewhere, and it gives you the results, but also on the side it says like broken down. Like let's say you search for products like cameras, and then it says brand name, price, and you sort of drill down into what you're actually searching for. And those are facets, because they show you various facets of the search results depending on if you want to narrow those down. And there are various facet types, like terms, so basically working with words, histograms for numerical data, ranges, statistical, and more. So here's a little example of facets. So we have that three speakers that I put into the index, and I want to do a facet, and here I'm doing a match all query, just against all documents, basically. And then I have a facet. I'm going to name it histo1, and it's going to be a histogram of the height field with an interval of 10, so every 10 centimeters. So if I run that, because it's going to give me back, search results, but I said size 0, so actually I don't want any search results. I just want the facet. And here's the histogram itself, where the entries are. Here's the key. That's the beginning of the range. There's one person in there, and at 170-some centimeters, and then two people at over 180 centimeters. So basically, it's an aggregation of the search results you get back. Here's another example. I index a few tweets from DPC12, DPC12 hashtag, which I'll show you in a little bit. And here I want to do a date histogram against the created at field with an interval of an hour. So I want to see how many tweets have been done every hour. So if I do that, here it's going to give me back this histogram and timestamp rounded to an hour and how many entries were in each one. So really easy to take that data and build some sort of navigation based on that, or whatever you want to do. Okay, so this is a really cool concept, and it's basically Rivers is a pluggable service that's running in the cluster, running on actually one instance in the cluster, but it has all the usual failover rules. If it fails, the cluster will restart it on another instance, and all that good stuff. And it basically pulls in data from external sources and indexes it. And it has it's a plugin, so you can write support for whatever. Currently, there's support for Twitter, MongoDB, CouchDB, RabbitMQ, RSS, and Wikipedia for some sort. So if you want to pull in like Wikipedia changes or something. But I basically wanted to just use the Twitter river to pull in some tweets and index those automatically. And it's really easy to do, because all you do, so here I just created an index called DPC, and I just say one chart, 0 replicas. I don't care about any failover or any resiliency or any of that stuff. And then I just give it a mapping. I just indicate that this is going to be a field of that format, so it knows how to index that properly. Everything else it'll figure out automatically what field types that is, those going to be. And all you do is you say, I'm going to create a river for this DPC index, and it's of type Twitter, and here's your little client account that I registered just to pull in that stuff. Go ahead and log in if you want. Filters, and then you give it basically what it tracks. Here I'm just tracking DPC12 hashtag. You can track by location and other things. And then I tell it where to index it to. It's going to go into DPC and with a document type of status. And I say bulk size 1 so that it refreshes on every tweet rather than pulling in 100 and then refreshing the index, doing bulk indexing. So that's what it is. And it's been running, I don't know, 20 minutes or so. So if I go and do a search, there's a whole bunch of tweets here. Let's see, I did, and then you can do whatever you want with it. You know, it's now that it's all indexed in ElasticSearch, you can do all kinds of queries, apply filters, whatever. So I thought I'd just write a little app to view it. So here it is. So here it's showing me the tweets, and then on the side here, with my awesome CSS skills, I put in a facet, so most popular terms. So I want to do an experiment. If everybody can go and tweet something with DPC12 hashtag, we'll see if this is updates. Come on. I'm going to tweet too. There you go. It's basically refreshing from the index here, and these things should be updating as well on the side with the most popular, most used terms. Nice one, Joe. It always happens, right? There's somebody who's going to troll, and he's the biggest one. All right. I'll leave it running. We'll see what popular terms for me will come up later. So that was rivers. This is another really cool feature which basically turns searching on its head. Usually you have documents indexed and then you run queries against them. And here you store queries as documents in the ElasticSearch, and then you run documents against them and see which query matches it. So you can do some really cool stuff with it, like if you want to do notification system of some sort, you can store queries in the system, and then as new documents come in, you can see which query matched for which user, for example, and notify them right away. As a sort of simple example of that, let's say I have a shop, some sort of shop system, where I want to be notified when new, like the cameras I'm interested in come in. So I created a shop index here, and then give it a little hint on the mapping that price is going to be a floating point. And then I store this thing in Percolator for the index. I'm going to call it Sean, like my friend Sean is looking for just cameras of any kind. Just my query is term query for camera. I'm a little more choosy. I'm not only looking for camera, I only want a price between $1 and $200. So we create 2 queries in the Percolator that way. And then we can take, actually let me run this because I think I deleted that index. It would be a shame if it didn't work. So do that. Do that, okay. And then you can do a query saying this is the index and document type. I want to percolate this document through it. Just type camera, brand, and here's price $250. So when you run that, it just says, okay, well, it matches the Sean query here because you wanted any camera. Or you can actually index a document and percolate at the same time if you don't, because this previous one didn't store a document, it just percolated it. This one will store it and percolate, and here's price is $150, so I expect that it'll match me as well. And here we go. It says Sean and Andrei. So it's a pretty cool way to do kind of reverse searches where you're trying to find what queries are matching the documents. Another really cool thing is index aliases. So each index name that you can have one or more aliases in it. And what that allows you to do is on-the-fly index switching, basically atomic renames, which is awesome for production deployments and so on. Let's say what you do is your actual index, you name it something like tweets, followed by a date or version number of your index or whatever you want to do in case you change the document structure or something else. And then you give it alias tweets. And your searches and queries all go against the alias tweet. And then when you want to update it, you create a new index with a new version, and then just switch that alias atomically. And all of a sudden, your queries will be going against the new index with the new content or whatever else you changed in there. So index aliases are really good. You can also use filtered index aliases, which is basically gives you a way to create a view into an index. So here I'm saying, okay, I want to add. Whoa, trying to click on that. I want to have index post, and I want to give it an alias post by Andrei with this filter. So now I have this index that's just post by me with that term. And that's sort of like a view into an index, which you can do all the normal stuff that you can do with index, querying and so on. Parent-child documents is a pretty interesting concept where you can create a relationship between documents. Basically, you put _parent field in the mapping, and you say, okay, so if we're talking about, for example, blog posts and comments, you can say the comment has a parent, post as a parent. And then once that relationship is established, you can run a couple of queries. One is has child, so you can run it and find all the posts that have children, so all the posts with comments. But more interestingly, there's a top children query, which, given any sort of other queries that you have terms and numbers and so on, it'll run it against the children documents, like all the comments, and then but actually give you back the results posts, which posts have comments with those terms or and so on. And you can set various parameters, like I want at least like 10 parent documents that have comments matching that. There's a quick example I have there. Hope I'm not out of time yet. So let's say I'm creating this index. So the comment is going to have parent type post. Just do that. And then I have a couple of posts, ElasticSearch stock, GeoTil stock. Let's do that. And then I'm going to put a couple of comments in. And when I index them, I tell them what post they go into via this parameter parent equals and then the document ID. So this will be one comment per talk there. Then you run this top children query, which is say, okay, I want to search comments. I want to find all the comments that have funny in them. And then these are various parameters to the top children query. And what it's supposed to bring it back is the post that had those comments, which is this one. So a really easy way to do sort of search against one type of document, and it'll bring it back the parent automatically. As GeoSearch, which I've used a lot in the product I worked on, and it's implemented as filters. So your document can have a latitude, longitude as a field type. Actually, multiple of them if you want. And once you index that, you can run filtered queries saying, okay, I want to find documents where the location is within this distance from a given point, or within this bounding box or polygon, and so on. It's works out of the box, and is actually one of the better implementations that I've seen. You can write plugins to extend or replace a lot of functionality in Elasticsearch in Java. And they're installable from GitHub, so you can just do plugin install and give it the GitHub URL, and it pulls in the plugin and installs it. And you can do a lot of stuff with plugins. You can have custom mapping types, scripting language support. I haven't mentioned it, but a lot of the various operations you can script in JavaScript or Python or a couple other things. Custom discovery mechanisms if you're running on a certain cloud provider that doesn't, out of box, it works on Amazon. But if you wanted to use Rackspace or something like that, you can do a plugin for that, admin tools and so on. There are a couple of plugins I installed that have to do with admin stuff. So let's see, there's one called Big Desk, and that's sort of an overview of your cluster where you can see. I only have one instance running or whatever, but if I wasn't, then it would show you basically information about all your instances of the cluster and your other clusters. So here's some basically how many documents I've stored, and so on. And there's another one called Big Head, which gives you something like this, where these are the indices I've created so far. These are the number of shards they have. Then you can do actions against them, like snapshot, test, refresh, and so on. Or you can go browse the data that I've stored there. There's all that stuff that got indexed. You can, I don't know, go do this dynamic searches where I type in Andrei name, go find that. Anyway, you can do structured queries and so on. So interfaces to this, I already mentioned REST. Basically, the easiest way to work with it is HTTP. Maybe not the easiest, but the most supported level. You can do Java and Groovy. There's integration, but there's a whole bunch of client libraries. Basically, for any language you can think about: Python, PHP, Perl, Erlang, Django, Drupal, Symfony 2, CouchDB. There's a Flume sync, which is really cool if you know about Flume. So you can use it for indexing logs and a bunch of other data. And that's about all I have time for. I have like 5 minutes for questions and answers. Here's some references to it. It's pretty active. Has a pretty active channel on IRC. You can read a couple of tutorials, which I found very useful for explaining the query domain-specific language, how to structure that, and how to get it running on EC2. Any questions? Yes. That comes up every time. How does it compare to Solar? Solar has had longer development and has some maybe extra features in areas of analyzers and some indexing things. But Solar is really, from what I understand, is pretty difficult to get running in the cluster, and this works out of the box. So that has a huge advantage in that regard. But yeah, there kind of depends on what you're after. Yes. You can update most things by HTTP calls. Some things you can't update once the cluster is running, like the number of shards that the index has. And then some configuration is actually in the file called ElasticSearch.yaml for like the cluster name, what the discovery mechanism is, what some index configurations, refresh time, and a whole bunch of stuff like that. But for index specific, like actually creating indices and configuring them in some ways by HTTP. Yes. I will show you the next slide. Joined in.
DPC Radio is a production of iBuildings. The materials presented are copyright of the speakers. This episode is released under a Creative Commons Attribution, Non-Commercial, No Derivatives 2.0 license. iBuildings is a full-service web development company specializing in PHP development. For more information on how we can help you with your next web project, visit our site at ibuildings.com. Thanks for listening, and we hope you'll join us again for DPC Radio.